Okay, so we're back with FGT 14.4. This one is similar to what we did before because it is an alkyl halide to an alkene, but because we're using a large base, there is going to be a difference in the rules it follows, and so that will make for a different product. So again, it's an alkyl halide to an alkene using a large base. And the general reaction here is we're going to have a cyclohexene again, or excuse me, cyclohexane with a CH2H, an I coming off of there. And then we are going to use NaOCH, CH32. And that is going to give us a product that looks like that. So it's a cyclohexane ring with a double bond off of the first carbon. And so if we jump in to the mechanisms here, we see we have that cyclohexane and then we have the Na plus, which is kind of over here. It's not like directly bonded, so there is, you know, a slightly positive and negative charge. And then HCH3, CH3. And so what happens here then is we have, let me draw the H over here. So we have the electrons from the O, and they are going to attack that hydrogen over there. The bond breaks to the carbon. And then we also see, excuse me, we see, sorry, it keeps moving on me. Oh my goodness. Okay, so we see the bond breaking here to the I. And so that leaves us kind of with this cyclohexane, right? And then we had the I drop off here. And so this is going to be slightly positive, and this bond broke. And so it has, this C has an extra negative charge. It has extra electrons because the bond, when the bond broke, the O attacked the H, the bond broke to the C. So that has extra electrons. And so what happens here then, we don't like that. We don't want that. So we end up with a cyclohexane with a double bond off the one carbon. And like I said in the beginning, it does follow some different rules. So it follows Hoffman's rule and not Zatsev's rule. And that just means that the way that it bonds, like I explained, the way that the bond is, the way the double bond happens is in a different location. So it follows Hoffman's rule. There is no carbocation rearrangement. And then it follows E2 rules like we discussed before. And those basically, again, just say that the substrate's anything with a beta hydrogen. It favors tertiary over secondary. It needs a good leaving group and a strong base. The solvent would be polar aprotic, which we saw there because the Na plus and the O negative, so there's no hydrogens directly attached to those. Heat favors E2 over SN2, and then with a hydrogen and the leaving group are anti-periplanar. So that about wraps it up.